I'll start up here. Thank you again very much for coming out this evening. It's a cold night in Southern California, so we're glad that you were all able to brave that. And indeed, as we were told we would have a full house, we pretty much do. We are going to make it worth your while. We have some terrific people here tonight. Before we get too far into this, though, you know that we're having, I hope you know we're having, an after party. And you're all on the guest list. So if you can join us afterward at MRO HiRISE, we would love to have you there. It's very close by. Here is Casey Dreyer, my colleague at the Planetary Society, to tell you a little bit more.
Matt pretty much covered it. I encourage you all to join us afterwards. One thing he didn't mention that I feel like that I should, we have heat lamps. It will be nice and toasty and warm. I encourage you to come join us afterwards for conversation, a toast to Carl Sagan, maybe buy a Cosmo, and we're going to have something that I call a Sagan Slam. We're going to have Carl's books out. Feel free to flip through them. We'll have an open mic if you feel compelled, or if there's a favorite passage you want to read, or if something Carl said or did moved you at any point in your history or past. Please share it with us. It's a casual, open, fun environment, so I hope to see you all there. Thank you.
So, as you heard, we are the guests of Southern California Public Radio. And as you know, this is pledge time for them. First time in 7 months that they've gone on the air and started having a bag again. That's just how public radio is. And it allows them to support a facility like this. We've done many programs here. We hope to do many more. Our next Planetary Radio Live, which this is not really an example of that, is December 15th. And we will be talking about the Curiosity mission with the two people at the top of that mission, at the head of the team that has put that incredible rover on Mars. We'll also have some live music. So please keep that in mind. It'll be on our site at planetary.org, and it will also be on the SCPR site under events. So hope you can join us then as well. It's going to be a great party. I was in this room just a week ago because I do some other stuff for KPCC, a series called Next, a monthly series about science. And I was getting ready for a conversation with Jill Tarter. And probably a lot of you know who that is. Jill Tarter is the former leader of the SETI Institute's Search for Extraterrestrial Intelligence, something the Planetary Society has also always been very involved with. More important for tonight, though, Jill was the basis for the character Ellie Arroway, who, as you may know, is the main character in Carl Sagan's best-selling novel, Contact, later made into the movie, which we will be talking about later this evening. I told Jill that I realized just a couple of days before that most of my heroes are scientists, and that no one, not Einstein, not Galileo, not Newton, rates higher in my esteem than the man that we are here to honor tonight. Carl Sagan was a scientist first and always, but he somehow managed to turn the contemporary practice of science into a popular art, and in the process made himself one of the best-known scientists of all time. It's safe to say that he played a role in tens of thousands of young people deciding to devote themselves to science. Millions more have had that veil lifted from their eyes, revealing the cosmos. So, my boss is one of these lucky stiffs. Bill Nye, the science and planetary guy, is the CEO, the Chief Executive Officer of the Planetary Society. He's in Chicago this evening. He had a commitment that was made long before we scheduled this program, which came together very quickly. But he did want to leave us with a greeting, so here is that virtual message from Bill.
Hi everyone, Bill Nye here from the Planetary Society. Thank you for coming to help celebrate Sagan Day 2012. Now, you know, I had Carl Sagan for astronomy for one class, and then I corresponded him a little bit after I got out of engineering school, and the guy changed my life. And I imagine the reason you're all here is because he touched your lives as well. So it's a wonderful thing that we celebrate his legacy. And for me, the big message that Carl wanted to share with the world was that science is this process, this way we know our place among the stars, our place in space. And the process not only leads to these remarkable discoveries, but it brings out the best in us. It's what humans do best. And so it's worth celebrating. So thank you all for being here. And I believe I would paraphrase Professor Sagan by saying, let's change the world. Thank you.
The man has a way with words. How many of you have seen Cosmos? I'm not surprised. Almost every hand in the room goes up. Sometimes, some people, both hands. You know, with all of his best-selling books, with that movie that is considered one of the greatest science fiction films of all time, many believe that this 1980 TV series was Carl Sagan's crowning achievement in sharing the essence and wonder of science with the public. Do you know that it remains the most popular series in the history of PBS 32 years later? We thought it would help set the tone for this evening's conversation, so with the compliments of Carl's life partner, Andrew Ian, who I'm told may be watching the webcast tonight, here are a few minutes from the first episode of Cosmos, A Personal Voyage.
The cosmos is all that is, or ever was, or ever will be. Our contemplations of the cosmos stir us. There's a tingling in the spine, a catch in the voice, a faint sensation as if a distant memory of falling from a great height. We know we are approaching the grandest of mysteries. The size and age of the cosmos are beyond ordinary human understanding. Lost somewhere between immensity and eternity is our tiny planetary home, the Earth. For the first time, we have the power to decide the fate of our planet and ourselves. This is a time of great danger, but our species is young and curious and brave. It shows much promise. In the last few millennia, we have made the most astonishing and unexpected discoveries about the cosmos and our place within it. I believe our future depends powerfully on how well we understand this cosmos in which we float like a mote of dust in the morning sky. We're about to begin a journey through the cosmos. We'll encounter galaxies and suns and planets, life and consciousness, coming into being, evolving, and perishing. Worlds of ice and stars of diamond, atoms as massive as suns, and universes smaller than atoms. But it's also a story of our own planet and the plants and animals that share it with us. And it's a story about us, how we achieved our present understanding of the cosmos, how the cosmos has shaped our evolution and our culture, and what our fate may be.
We wish to pursue the truth no matter where it leads. But to find the truth, we need imagination and skepticism both. We will not be afraid to speculate, but we will be careful to distinguish speculation from fact. The cosmos is full beyond measure of elegant truths, of exquisite interrelationships, of the awesome machinery of nature.
The surface of the Earth is the shore of the cosmic ocean. On this shore, we've learned most of what we know. Recently, we've waded a little way out, maybe ankle deep, and the water seems inviting. Some part of our being knows this is where we came from. We long to return. And we can, because the cosmos is also within us. We're made of star stuff. We are a way for the cosmos to know itself. The journey for each of us begins here. We're going to explore the cosmos in a ship of the imagination, unfettered by ordinary limits on speed and size, drawn by the music of cosmic harmonies. It can take us anywhere in space and time. Perfect as a snowflake, organic as a dandelion seed, it will carry us to worlds of dreams and worlds of facts. Come with me.
Now, I know after that, you'd be perfectly happy just to sit here and watch the rest of that episode. So go get a copy. We will talk more about Cosmos later, and we'll show you one more excerpt from that truly groundbreaking and amazing series. Talk about A Way with Words. Here's someone else with A Way with Words. Louis Friedman is not just one of the 3 co-founders of the Planetary Society, as was Carl. He is more than its Emeritus Executive Director. He did more than plan deep space missions for JPL and NASA. And he's not just Mr. Solar Sail. No, far, far more than any of these, he is a lifelong Yankees fan. Please welcome my former boss, Lou Friedman. He says you got to bring that up, as if that's not
already. I started at a disadvantage. You know, you remind me, following Carl on something like that. It's a little. That's a really big disadvantage. One of the greatest thrills I ever had. I was in New York to hear with Carl. He was addressing the general a meeting that was in the General Assembly of the United Nations with representatives from all the countries there and some big scientific symposium, and he was the featured speaker. And about 7:30 in the morning, my phone rang in my hotel. I'm really sick. I can't make it. Would you go and deliver my talk? And so I had to go unprepared to the United Nations to make this thing. And the only opening I could come up with is the same opening I'll give the people tonight, which is when I stepped to the podium, I said, I'm not Carl Sagan. And it was evident right away afterwards.
I'm sure you did just fine and there were no international incidents.
Not that I know of.
Hold that up a little closer to your chin.
Okay.
And tell me, how did you meet Carl?
Well, I actually met him, I think it was 1975, thereabouts. I was working on a JPL, one of the advanced studies, I think it was missions to the outer planets, and there was a meeting at Cornell, and Carl was the host of the meeting, and he was serving on some NASA committee having to do with robotics. And so in the preparations of that meeting, he contacted me because I was doing the studies for that, of the mission work that was going on, and he was trying to prepare for the meeting, and so we went over a lot of things. And so I met him in the context of that meeting, and then I went to Cornell and attended that meeting. And so that's when we got to know each other, but we didn't really work together at any time, except for a few occasional intersections on studies. Until he came out here in 1979, I believe it was, to work on Cosmos and to work on the Voyager mission, both of which were happening, centered out here in Los Angeles. So he took a year, I think maybe even a 2-year leave from Cornell, came out here working on the Voyager mission with JPL and on Cosmos with public television. And the work with Voyager mission led him to spend a lot of time with Bruce Murray, and that's when Bruce and he began talking about this curious situation in planetary exploration where the Congress was cutting out missions that the public was interested in. And let's do something about it, and that's what led to the beginning of the Planetary Society. Boy,
history repeats itself, but that's a topic for another day. Nobody had ever done anything like this before, as far as I know. Setting up a nonprofit to boost something that you wanted basically the government to do more of and people to know more about the value of. It must have been kind of crazy, shaky times at first.
It was an interesting idea. In fact, I was working, when I first began discussing this with Bruce and Carl, I was working in the U.S. Senate on a 1-year congressional fellowship. And I would come back to Pasadena every few months, and Bruce Murray talked to me, and usually I'd start out by giving him a report, and he'd cut me off right away and say, no, I have something I want to talk to you about. And Carl Sagan and I have been talking about this, and he began describing.
This is when Bruce was still director of JPL.
Yeah, he was director of JPL, And the idea was form a grassroots organization for what can people do if they really care about planetary exploration. Well, they could send money to NASA, but we do that in our taxes, and that wasn't enough. They had to have some kind of public interest activity. Well, I had been thinking along the same lines, but more observing what was going on in the commercial space interest with remote sensing, figuring we need an organization that can be an outside influence on space exploration. And so then Carl came back to Washington. He visited me in my office at one of the Senate office buildings, which created quite a stir among all the staffers, and said they were going to set up this organization. And he and Bruce knew exactly how to do it. And would I come and work for them? And well, how could I refuse working for Carl Sagan and Bruce Murray? So, and they knew how to do it exactly. So that's what happened. I went to work. We started the Planetary Society. They knew exactly what to do, and I just carried out their orders.
I see. You're being kind, aren't you? What was Carl's role in the society?
Well, it's interesting. Carl is an extraordinary individual, but when he didn't know you, he could be a little standoffish. He wasn't sure who you were, and I'm not a scientist, so he was even a little more unsure about me. I'm only an engineer, and I see that caught some of the people's attention here. And so, at first we weren't, he didn't take my phone calls. It's really hard to get a hold of him. And Bruce Murray was director of JPL. He was kind of busy too. So at the beginning, we were kind of trying to feel our way. What were we going to do? And it turned out they really didn't know exactly everything to do. We really had to wing it. And but we got great support in the planetary community. And Carl wrote some awfully good letters to important people for support, to fellow scientists. And most of all, he intellectually guided the organization. We didn't know what we were going to be. We had no idea. And he and Bruce, remember hours of discussions, usually arguments.
Yeah, I was going to say, you obviously all had a lot of respect for each other, but I have it on good authority that you were, we'll call it, strong advocates for your diverse positions and opinions. I wish I'd been around to watch one of those arguments.
Well, Carl and Bruce had strong positions. I never did.
Sure.
And it's really true. I can remember many hammering out positions that we were going to take with Congress, or writing congressional testimony, or advocacy that we were going to do in public op-eds or something like that. It was very hard work to get an agreement between the two of them and then me to try and interpret what that was and make it an agreement between the three of us as to exactly what was said and how it was said. And we would, to get one sentence done sometimes, it would take several hours of discussion, usually on telephones or pay phones in some place or another. But Carl and Bruce were famous for being rivals and advocates of very different positions. Bruce Murray had, and with due respect to the people here in the audience, the somewhat more conservative Caltech position about being skeptical of some of the discoveries that were being made and some of the speculations about those discoveries. Carl would keep us, as some people said, at the edge of speculation. And so the two of them would be arguing about the interpretation. Carl, you shouldn't have said it this way. And Carl would say, was there anything incorrect about it? And they would go back and forth on this for quite some time. But the interesting thing is they were absolutely identical in their determination of what we should do and how we should do it. And it all came out, as you can see, with the Planetary Society, but also with so many other products of space missions and great agreements.
And here we are 32 years later.
Yeah, this, by the way, I want to congratulate you on the 10th anniversary of the radio show. I think Bruce Betts pointed out earlier other anniversaries that this is connected with, but this is also the 8th anniversary of the launch of the Venus Express. And that's kind of interesting that that anniversary on this date coincides with the date of Carl's birthday, because it was Venus that launched Carl Sagan's scientific career. His early scientific work was on the studying of the Venus atmosphere and the implications of the very heavy atmosphere, which led to the creation of a greenhouse, and not just a greenhouse, but a runaway greenhouse, which led to, of course, so much of his work in the whole subject of planetary atmospheres and climate change and all of those subjects.
I wish we had a half hour for each of these folks, but we don't. So
You mean my time is up?
No, yours, you get to stick around. You get to
Okay.
stay on the bench. You know, you move down like Johnny Carson. No, stay where you are.
Yeah, that's, by the way, one more thing.
Yeah.
We didn't have a name for the Planetary Society. And Carl was going on the Johnny Carson show, and he said, you know, this would be a good place to announce the existence of our new organization. I said, well, don't we need a name? And he said, well, yeah, get one, and we'll put it all together. So we had about a week, and I started coming up with ideas, and Carl rejected them all, and we were kind of groping, and I couldn't get him to answer the phone. So finally, I wrote up the press release, and I called it the Space Society, or something like that, I guess. And I said, I'm going out with this in about an hour. If you don't think it's the right thing, let me know. The phone rang, like as soon as I got it. That won't work. Give me 30 minutes. And that's where the planetary, he came up with the name Planetary Society on the spot, and then he went the next night on Johnny Carson and announced our existence.
Nice work, both of you. Thanks, it's obviously stuck with us. We're gonna bring up our next guest. Kip Thorne has been a member of the Caltech faculty for more than 45 years. It was more than 20 years ago that he was named the Richard Feynman Professor of Theoretical Physics. He has mentored more than 50 other PhD physicists, many of whom have gone on to become leaders in their fields. Kip's research is focused on gravitation physics and astrophysics, with emphasis on relativistic stars, black holes, and gravitational waves. He co-wrote the book Gravitation, which is how most of the scientists working in the field now learned about general relativity. His popular science book, Black Holes and Time Warps, Einstein's Outrageous Legacy, is still very much in print and available. I saw it on Amazon just a couple of days ago. His list of awards and accolades is about a light year wide, so we won't go into all of that, but I will tell you that we are honored to have him join us here on stage. Please welcome Kip Thorne. No, it's really, it's okay.
Thank you, Matt.
Thank you. Thank you very much for being here.
Thanks.
You know, by most accounts, Carl was a really smart guy.
He was.
Okay. Yeah, that was a joke. But when he needed to get a fictional character to the other end of the galaxy in 10 minutes or so, 10 minutes or less, you were the guy he called. Were you already acquainted?
Oh, yes. I knew Carl since before you did, Lou. We go back to about 1970. The period he had just recently moved to Cornell. I was going back and forth between Cornell and Caltech every now and then. I was based at Caltech, but I often visited Cornell, and I got acquainted with him there when I was visiting my colleagues who were also working in similar fields in astrophysics. And then he was spending time out here on the Pioneer 10 mission, and then the Pioneer 11 mission, which presaged Voyager. And so I would see him out here. I remember a lovely evening in his home with him and his wife Lynda in Cornell, probably 71, 72. We just became very good friends, although we were working at opposite ends of astrophysics.
So did he just call you up one day and say, I'm writing this book called Contact, and I need a way to get somebody from point A to point B?
And no, he called me up and he said, I have written this book named Contact. It's in page proofs. But I'm feeling a little uneasy about some of the science of how you get from here to Vega. I have my crew, which included the heroine who became Jodie Foster. I had my crew going through a black hole, and I know you're not going to like that. Can you help me rework it? Get him out of the hole.
Yeah, dig him out of the hole, the black hole. I shouldn't have said across the galaxy. I forgot it's Vega, which is not too far, right?
So he sent me by overnight express mail a copy of the whole book. And my daughter was just graduating from UC Santa Cruz I guess the day after that. And so I rode in a car up to Santa Cruz for my daughter's graduation, read the book, and struggled, well, how do we make this honest? Because Carl's specialty was not general relativity. It was not curved space-time. And so I realized that what he really needed was a wormhole to travel through rather than a black hole. But I also realized, just did some back-of-the-envelope calculations on the trip, and realized that there's a major problem how you hold a wormhole open so it won't implode on itself. And so I sent him a few pages of calculations and a discussion of these issues. So he actually rewrote, I don't know, maybe 5 or 10 pages of that book in page proof, which did not make his publisher very happy, in order to change from traveling through a black hole to traveling through a wormhole.
Had you given any consideration to this theoretical possibility prior to hearing from Carl?
Well, the idea of wormholes goes back a long time to Ludwig Flamm, 1 year after Einstein formulated his general relativity theory. So I was well aware of it. My mentor, John Wheeler at Princeton, had thought some about wormholes and had realized that they will implode on themselves if you don't do something to hold them open. But he didn't speculate about what was required to hold them open. But wormholes were such far-out ideas that I don't think anybody, and certainly not me, were paying much attention to wormholes at that stage. We were more interested in things that we were sure are out there, like quasars and how quasars can be powered by black holes. And so, no, none of us were thinking about wormholes until Carl called me.
And I've read that this led to a whole new line of theoretical physics investigation, which may continue today.
Yeah, so Carl sort of broke my mental block of not wanting to think about this. And so I began to think seriously, can a wormhole be held open? How do you hold it open? And then I realized, we're thinking about issues in warped space and time that are far, far, far beyond what we as human beings can ever do in the laboratory. And yet, thinking about these questions of can a very advanced civilization hold a wormhole open and travel through it, that is a thought experiment. And working on mathematical calculations with the laws of physics to find answers, that's a powerful way to do research. It focuses the mind on specific issues. You come to realize what is it that governs whether or not wormholes are possible or whether or not time travel is possible. And that leads you, as you struggle to answer those questions from the laws of physics, leads you to a much deeper understanding of the nature of space and time. So I started publishing in this field, and when I started publishing, my close friend Igor Novikov in Moscow phoned me up with great joy. He says, if you can publish about this, then so can I. I've wanted to for years, but it was never respectable. And so it's now more or less respectable. It has become a very serious direction of research, but it really is all due to Carl breaking our mental block, we as a community who work on these issues of warped space and time.
I would love to follow up on this, but of course it's not really what we're here for. When I invited you to join us tonight, at Lou's suggestion, you didn't hesitate. And we all have our reasons, but why do you hold Carl Sagan in such high esteem?
Well, there are several issues. One is a personal issue. He was a man of whom I was very fond, both because of his intellect, but because of his warmth as a human being, because of his caring. So that's one aspect. The second aspect is his science. He made major contributions, giant contributions to our understanding of the planets in the solar system, Europa, the idea that there may be subsurface water under Europa. He was able to look at what we knew about the planets and the satellites of the giant planets, look at them, integrate those data, and make very informed speculations that a number of which turned out to be absolutely correct. The high temperature of Venus you mentioned. So I respected him enormously as a scientist, but also I had tremendous respect for his communication skills and his dedication to communicating to the general public about science. I remember sitting in his office at Cornell on a number of occasions when a phone call would come in from some journalist who had a question, really needed help, and it wasn't something where Carl was going to become on a headline. Carl Sagan says it was background briefing. He would always break for just a few minutes to give a background briefing to a journalist who needed help. And that's not something that I know of anybody else who would do.
Lou, I was hoping you'd jump into this as well.
Yeah, I think especially today, a lot of people don't realize how strange it was for a scientist to be willing to communicate to the public. They got no credit for it in their science field at all.
In fact,
it was held
negative
against them. Yeah,
right?
I remember scientists coming up to me, "Oh, you're working with Carl Sagan. Well, he's just a popularizer." And he was victimized by his being willing to spend time in popular explanation of science. Both by some small-minded colleagues and even in the non-election to the National Academy of Sciences, which was a great travesty of justice. But today, we consider education and public outreach part of our science jobs, part of our space program jobs. But back in the day, it wasn't. And Carl really broke a whole lot of new ground in being willing to do that and willing to educate a lot of people about that. And I think he set a lot of precedent in that regard that lives with us today.
I would like to comment just on the National Academy issue.
Which you're a member of.
I'm a member of the Academy. I watched the election process. It's a Byzantine election process. Carl had firm and overwhelming support from the astronomers and astrophysicists, who were the people who were in his field. The objections came from people who were farther away, who weren't close to his field and did not know or understand and appreciate his science. And so, yeah, he was victimized in some sense, but not by those who knew his science. They were very strong supporters.
But didn't his work help to turn things around and create what we have today, where it is?
Well, indeed it is. I mean, his communication to the public has turned things around in terms of public understanding of science, public appreciation of science. But his contributions to planetary science themselves were really very great and had a big impact on the development of that field.
I remember when he wrote the first article in Parade magazine, and got a lot of criticism. Why are you wasting your time writing for Parade magazine? And the sheer numbers of people who read Parade magazine and learned about the planets and about space travel and about science was such a great service of him to put in that kind of time to do that. It really made a difference, and now people are willing to do that in many degrees of publication and, of course, on the internet to an extent that we couldn't have imagined back then.
You've been involved in this area. We already talked about your popular science book. We see this now from so many scientists.
Yeah, I think it's much more respected now. I never had any of the kinds of problems that Carl had, but I was coming on a little later, following in his footsteps, not nearly as successfully, but certainly popularizing a lot more than most any of my colleagues in my field. And I think I have felt appreciated by my colleagues for it, and I think it's a different era than it was.
Thank goodness. Lou?
Don't you think that kind of thing also made it possible for so many scientists now to be willing to write these books? I mean, Stephen Hawking writes a book about a subject that very few of us understand, but we all buy the book, but it brings it to so many more people.
No, that's right. I think Carl did lay the groundwork for the rest of us to pursue public communication.
I'm going to go ahead and move on to the next little segment of our program, and it is to bring up somebody who is closely tied to what we've already heard and actually has a brand new project underway with Kip Thorne that perhaps we'll talk a little bit more about. Lynda Obst is one of Hollywood's most successful film and television producers. You've seen her work if you've seen Sleepless in Seattle, The Fisher King, How to Lose a Guy in 10 Days. The list really does go on and on. She wrote the best-selling book, Hello, He Lied, and Other Truths from the Hollywood Trenches, and blogs for TheAtlantic.com and the Huffington Post. Her second book about the entertainment industry will be published by Simon & Schuster in the spring of next year. She studied the philosophy of science at Columbia and describes herself as an abiding science geek. But I don't know why that's such a big deal. I mean, isn't every Hollywood producer a science geek? We wish. Please welcome Lynda Obst. So, Lynda, of course, what I left off of that list is a certain film that you served as executive producer for. What made Contact stand out from all those other great works that you shepherded? It didn't stand out?
Well, it was sourced by Carl. It began with Carl. It began, I think it was the first or second project that I began when I came to Hollywood from the Times, where I was able to, when I came out here kicking and screaming, I had no intention.
She had been a science editor for the New York Times before she came out here.
So I wasn't really...
There are not many movie producers who have a history of being a science editor for the New York Times.
I had no idea what I was doing here. I was like, what am I doing here? My desk had this big skirt on it made out of leopard skin. I was like, what is this skirt? And I had suddenly stationery where the logo went to 3/4 down the page, and I had no room to write anyone because there was so much logo on the paper. I was like, dear writer, was like all the way down the page. It was so bizarre. I was so dislocated that in fact when Carl and Annie came out to work on, they were my best friends, to work on Voyager, Carl was working on Voyager and to work on Cosmos. It was such an incredible relief to me that I didn't go to the office. I just sort of hung out at their house and hid from my office. And I think that's part of the reason Contact was born, was I was afraid to, my office was also at a hotel. It was housed at what we called the Bad Girls Motel, because there was a big Donna Summer poster right over our office that said Bad Girls. That's where I had to go to work every day. Because it was Casablanca Records and Films, the Bad Girl Motel. And I was like, Annie, I don't want to go there. So I would just sort of hang out at the house and talk to Carl and Annie, which was always my favorite thing to do anyway. I mean, why not? If you could, who would you rather talk to? In fact, I met Lou at that same time, and Kip at that same time. Everybody on the stage except for you, Matt.
I wish I'd been there. Can I break in? Because what's this about a blind date?
Well,
who's going to tell the story?
You're going to tell the story. As I was lounging at...
This is characteristic. She says, you're going to tell the story, then she starts
I proceed to tell it. You're going to tell it. Go. I have no voice.
So there was the, I guess, the world release, the celebration of the world premiere of Cosmos. And Lynda had worked on this, being in charge of foreign translations, as I recall, of Cosmos. And I had never met her. But Carl Sagan called me up one day, shortly before this world premiere, a big event out at the Griffith Observatory. And he said, I'd like to set you up on a blind date with Lynda Obst. She's a producer in Hollywood, and
she likes scientists.
And she likes science. Yeah, that's right. He said she likes scientists, so don't be scared of her. But you have to go and hire a tuxedo if you don't own one.
Is that why you had the maroon tuxedo?
Oh, I had maroon. I thought I had baby blue. I didn't want to be in black.
It was the worst color maroon tuxedo I ever saw. It's the only reason I didn't marry you.
Is that worse than my yellow pants?
It was worse. It was the worst color tuxedo I ever
Lest
saw.
anyone get the wrong idea, Kip's wife is sitting right back there.
My other best friend.
And they're all good friends.
So anyway, Carl was responsible for our meeting. We had a great blind date at the premiere and celebration of the beginning of Cosmos. And then we dated for a few years after that until I met my wife and married her.
I think we broke up before you met Karen. Just to make this clear. But we have remained best friends, and we worked on Contact together, and then we began a new science-based project. But to answer your question more directly, not what Carl did for Contact, and then also then is the source of my project with Kip, is that, and I'm a total Saganite, that's my sort of religion, I call it, if I had a religion, is that he taught me that the truth, the laws of physics, are more interesting than anything we can make up. And so in the movie, the narrative is informed not just by a great story, which it is, but by the rule that nothing, no plot point can defy the laws of physics. And just like when he was turning in his galleys, he had to get it right and called Kip and changed the galleys. So that's true throughout.
It wasn't the galleys, it was the page proofs,
Page
which is a much
proofs are
bigger
even,
deal.
That's $100 a page. So more, actually.
You told me that there were other ways in which he participated. Something about Carl participated. Something about workshops.
What we did, okay, is that we began the project before we even had a screenplay. The movie, we had a book, right, but we didn't have the movie yet. We hired the director, and we had a series of workshops where we invited experts in every field that the movie involved, from futurism to religion versus science to planetary astronomy to wormholes. Kip was part of the workshop so that we could draw up the wormholes for our production designer and so our director could understand them. Every expert that Carl could identify, which he really could, sat with us for maybe 2 days or 3 days each, and we transcribed them with a court stenographer. That's how old-fashioned we were. And we sat, Annie, myself, the screenwriter, the director, and we sat, and we had we were in a hotel room. We sat through lunch, we worked all day, and I have the most incredible set of transcripts. And we debated, we talked, we milked, and plumbed the depths of every expert we could in all these fields. So before the writing began, both the writer and the director, and Annie and I got in there too, just interrogated and imagined every possible facet of the ideas conceivable in every aspect of the material of the film. This is something we also did in Interstellar, Kip's and my project. And we did it with Mr. Spielberg, who was our first director.
Which is going to come up in another moment or two here. So you taught him a few things too. I guess you taught him how to write a screenplay.
Well,
yeah, grab that
the
mic.
most hilarious, truly hilarious, and Lou can appreciate this because the dialectic of working with Carl is truly challenging. Was truly challenging because nothing is a given with Carl. So you tell Carl there are certain rules that are sacrosanct in screenwriting that every screenwriter knows. And Carl says, like, there are 3 acts in a screenplay. And Carl says, why? Okay, you need to know the answer to this question. You can't say because it's custom. It's customary because every screenwriter does it that way for the past 60 years. That doesn't work with Carl. Carl says, is it a priori? Okay, fortunately, having done philosophy of science, okay, I can actually answer that question. No, it is not a priori. It is a posteriori, okay? However, okay, I believe it comes from Greek drama, I am now going to find my source, okay? I've got to go to Sophocles to satisfy Carl on why there are 3 acts in screenplays.
Couldn't you just go to Sid Field? I mean, that's a
Oh,
Hollywood
no. Sid Field doesn't hold it with Carl, okay? Because Sid Field is customary, right? So literally every question, like you can't presume anything with Carl.
We had that same discussion when we were writing direct mail copy to get people to join the Planetary Society. We'd have these really expensive direct mail copywriters who would put it in their language, and Carl would say, no, it can't be done. And they'd say, well, that's the way it's always done. That's how it works.
No, that's how it works is the worst possible answer
Absolutely
you
right.
could ever give Carl. He's so not interested in how it works. That, you know, that you have to really give him sort of scientifically based answers. Do you know, it has to have a reason, a cause. It has to be perfectly logical. Do you know, it has to derive from some fundamental principle.
Clearly the process worked because it resulted in, I don't know about you folks, but one of my all-time favorite films, science fiction or not.
Thank you.
I watched it again. I think I got the Blu-ray copy at home, and I had forgotten how terrific that movie is.
It really is, isn't it? I'm so proud of it. One of the things, there's a few things I'm really proud of. There are subtle things in there that you can see come from our workshop. We even workshopped what it was like for women in science at the time to go through graduate school and have Ellie's experience. And we talked to women who were in graduate school, lots of women scientists who were in graduate school during a very difficult time for women in science to be in graduate school. Carl was obsessed with this. He was such a feminist, okay? He was the most extraordinary feminist for a man who came from really the 40s, do you know? And really didn't come from feminism at all. And he experienced, and I know he did with Lynn Margulis, he was very sympathetic to her experience, you know, women really not being treated well as scientists in graduate school. So we workshopped this, and we had women come in and tell anecdotes that you can see in the little background, you know, of Ellie's experience and how she's treated by her professors and stuff like that. And the most gratifying thing, consequentially, about Contact is how many women astronomers there now are. There's almost parity in science now in astronomy. And I feel like that's, and so many women that I meet at astronomy conventions tell me that Contact drew them in.
Stick around, because you'll see some more of those women in the next panel that we'll have up here this evening, some of those young scientists.
It moves me so much.
So years go by, and you find yourself working with your old blind date partner on a new movie called Interstellar, which I guess you're both very involved with. Tell us more. When are we going to be able to enjoy this?
You know...
pick up that microphone.
Oh, sorry.
There you go.
I went to Kip in a moment of despair, just like I went to Annie and Carl in a moment of despair. It's like, what am I doing here? And I said, and it was another moment just like that, I said to Kip, I hate my job. I hate this movie business. It's full of crazy, stupid people making movies about flying men. Tell me, how's the gravitational wave detector going?
As we should say, the Kip is one of the founders of the LIGO project, which is searching for gravitational waves and back to real science.
And I said, it's the only way I can do a science movie. And I think it's another way that what you guys were talking about before, how can we get the public excited in a mass way about science the way we are? And I said, Kip, and what's the most extraordinary thing that could happen as a result of the gravitational wave detector? What could LIGO find that would be epochal, game-changing? And that began our conversations. And Kip has become the most, like Carl, the most extraordinary collaborator in terms of being able to game out a plot using real science.
That's not what you always say. Sometimes she will just scream at me, this doesn't work, this doesn't work.
So what is the most extraordinary thing? That,
You'll find out when you see the movie.
Now you see how good he's gotten?
Well played.
I have a written contract with Paramount that says I can't reveal that. But I can tell you, because it's very widely known, because it was in the first draft of our treatment before we signed on with Paramount, that the movie does open with LIGO detecting gravitational waves from the most phenomenal source you can imagine.
Ooh, I'm intrigued. So how is this similar to the experience you had years ago with Contact?
Well, Annie and Carl weren't there, so it's not similar in that way, and that's irreducibly perfect. And so it's not similar in that way. I think we learned...
I can't even feel badly that she thinks more highly of Annie and Carl than me, because so do I.
But Kip is an incredibly great partner. I love working with him. It's taken almost as long.
You told me 10 years when we began this project. So
and we're on 7.
We're on 7.
And it's going to be 7.
Well, you
So-
mean it's coming out this year?
So it'll probably
be 9. It'll be 9.
I ask again, is it even possible to say when this might reach the big screen?
I believe it'll be 2014, summer 2014.
So why is it that Hollywood movies take as long as missions to the
Good
outer
ones
planets?
do.
What's that?
They take as long as missions to the outer planets. I've never...
Only when I do that.
We can go to Jupiter and the time it takes you to make a movie.
That's a really good question, Lou. That's a really good question, and now I will go home and cry.
Kip, were you going to say something?
Well, I was just going to say that they don't take as long as it took to get LIGO funded. But the machinations of getting LIGO funded, which were pretty enormous, dealing with getting through through Congress as well as through NSF and various reviews and fighting battles with colleagues whom you thought were supportive, and it wound up not being. Anyway, real machinations. They're nothing like the machinations that go on in Hollywood to get a movie made. I just am happy to be. Oh, Hollywood's much worse. I'm just happy to be sitting back away from that side of things.
You're really right about how long it took. I first met you. You won't remember this. The year I started at JPL in 1970, you were working on gravitational wave detection at that time, and that was the beginning. I had done a thesis on testing of gravity with spacecraft, and you were working on that subject then, and it's finally.
That's right. It's been a lifelong project, but we are very close now.
Speaking of the edge of science, we're going to bring up the fourth member, the last member of this first panel of the evening. One of the many centers and institutes down the street at Caltech is the NASA Exoplanet Science Institute, or NEXSCI. Chaz Beichman is its executive director. Here he is. His own research goals include the search for planets circling other stars, and such telltale evidence of those as debris disks around young nearby stars. This research led to involvement in many space-based and ground-based astronomical missions. Please help me welcome Chaz Beichman of NEXSCI. Chaz, Carl lived just barely long enough to see confirmation of the first planets circling other stars, exoplanets. He was thrilled. Now we're racing toward knowing about 1,000 of these. Just this week, we learned about the discovery of another world in the so-called Goldilocks zone, one that, if everything else is okay, might be able to support life as we know it. Are these good times for someone in your line of business?
I think it's really a fantastic time for anyone who's interested in precisely the questions Carl was interested in. Where are the venues for life beyond Earth, whether it's in our solar system or now, as we know, in other solar systems? The very first extrasolar planet, 51 Peg, was discovered just a few months before Carl died in 1996. 51 Peg was discovered in 1995 by the Swiss group, the same group that just a few weeks ago found an Earth-sized planet orbiting one of the closest stars to us, Alpha Centauri b. And I think Carl would have been thrilled with all the discoveries, but perhaps that one almost the most. I mean, this is the closest star to us. It's a few light years away. I mean, we could, you know, Voyager, if it was aiming in the right direction, would be there in 40,000 years.
No, we got to get a solar. We have to get a solar
Kip
sail
intervenes and gets us there quicker. So I think the excitement of that would have thrilled Carl completely. I'll point out that he was on the West Coast just a few months before he died, sitting in the office with me and Charles Alachi, was soon to become the director of JPL, but then was in charge of doing science missions. And was there saying, you know, we ought to do this mission that Bill Barucki up at Ames would like to do called Kepler. And the Kepler mission is now up and has found probably 2,000 or 3,000 candidate planets and is revolutionizing our ideas on planetary systems. At the same time, we are pushing other ways to find planets more close by, identifying planets in the habitable zone, eventually even finding planets where we would find evidence of photosynthetic products in their atmosphere. Terrestrial planet finder. So these were all the sorts of things Carl would, I think, really have loved to have seen. We certainly miss his voice helping to push those in the public arena.
You know, it was in that same. Yeah.
No, go ahead. I was going to.
In those same years, Carl was urging me to get into this idea of planets around other stars, and it's going to be a hot field, and there's going to be discoveries in it. And I was kind of against it because I'm an engineer. I want any place you can't go to. Why just study remotely? That's not. That's just done with telescopes.
But you had the way to get to them, the solar sail.
Well, I didn't know it then. But
you can go. You just have to be patient.
Yeah. So I was kind of like resisting it. I said, well, these aren't about. We're about missions, and this is not. So I was, and he was really patient and understanding, and he right there on the cusp of a whole new field, which was just beginning at that point, and he really saw it, and of course can not only turn me around, but then we actually began funding little projects in exoplanet discovery.
And it's the fastest growing field, or one of them, in astrophysics. When we'd have the first meetings of a small group of enthusiasts at an American Astronomical Society meeting, one side of this room would be the total number of people who would show up. Yeah. Now a third of the talks at the American Astronomical Society meeting, parallel sessions with hundreds of people engaged, are all there, and it's just a remarkable time. It pulls together people with interest in geology, astrobiology, astrophysics, planet formation, star formation, and it's really a very exciting period.
So how does NextSci support exoplanet research?
I think the one that's most relevant here is we, through NASA, we select 5 or 6 young students who've just graduated from graduate school, who are their first steps as young scientists, as postdoctoral fellows in what we call the Sagan program. And we have a picture of Carl, not this one, but another very nice picture, and underneath it says, "Somewhere something incredible is waiting to be discovered." And there's one of, I think, the favorite quotes I have of Carl, that's why we put it on his picture. And we get typically 75 to 80 applicants every year. We choose 5 or 6 of those students, so it's oversubscribed by 10, 15 to 1. And these are the best of the best of the best scientists in either theory, observation, or instrument builders, because we want people to actually build the instruments that do the missions that take the next step. And I think it's one of the key functions that we do at the Exoplanet Institute. We do other things for the professional astronomer. We allocate time on the Keck telescopes. NASA has a portion of that. But I think the one that's most important and most reflective of Carl are the young scientists who come out. We had Ann Druin at the announcement of starting this fellowship program at the American Museum of Natural History. She was there. Neil Tyson hosted the event, and all the students really take something away and learn a little bit about Carl, and I think it's really a great testimony to him.
and was on Planetary Radio very soon after that. And she was unspeakably proud of this program and how it honored Carl's legacy.
It's
Lynda?
perfect. It's just what he would have wanted.
And you have several Sagan Fellows, I think, in the audience tonight. One of them, at least, is going to join us here on stage shortly.
We have every couple of years, we have a symposium where we bring all the fellows, both present and past, out for a 2-day meeting where they all get to meet with each other, discuss their work. They all give 20 or 30-minute talks. So we've had 30 of them out here just yesterday and today, and so a number of them are going to be in the audience, and I think at least one will come up on stage in the second part of the show.
I wonder if you'd care to say, because the search for exoplanets certainly will continue, but there are budget challenges, as always. You mentioned the Terrestrial Planet Finder, which was put on hold by NASA some time ago. I bet you wish Carl Sagan was around to advocate for that.
Well, the discussion of how you make movies in Hollywood is indeed the sort of the things we see in greater or lesser extent in moving scientific projects forward. And the discovery of 51 Peg, the planet orbiting that star, and the discovery of the moon rock that was thought perhaps to have early evidence of microbial life from Mars, all happened at once around 1995. And that led to the government saying, we really ought to be investigating this. And serious money went back into the program. We started the Spitzer telescope, which has done a lot of this work, looking at following up transit, studying debris disks around stars. We started the Space Interferometer mission, we started the Terrestrial Planet Finder, and we started the James Webb Telescope, all roughly at the same time. Spitzer went.
And we started the Mars program.
And the Mars program started up.
Which
all
led
that
to spirit and
started at the same
opportunity
time.
and curiosity. Yeah.
And all those came out of this one really remarkable moment with 2 great discoveries, one in the solar system, one outside the solar system. The Mars rock proved probably not to be evidence of microbial life, but the planet part has just taken off. And so of those 4 missions, Spitzer has gone and had a very successful, now almost 8 or 10 years of observation. The James Webb Telescope has grown a little bit in budget, will take a little bit longer than we thought. That never happens in Hollywood.
Never.
But when it comes along, it will be a spectacular telescope. But it has certainly frozen the budgets for many other things we would like to see. But we certainly have great hopes for what we'll do both in exoplanet work and other parts of astronomy.
You have a quote on your, I don't know if it's your bio page, but you mentioned some of these setbacks, and you say, it's all right, we've been looking for we've been trying to find this stuff out for 2,500 years. We can wait a little longer.
I'm getting a bit impatient, but these questions will get answered.
And Carl would point out, it's not about the planets caring when we find them, it's about us and what we're doing at this time. And there was somewhere in the Planetary Society, I'm not sure if it's the website or a Facebook page, they've reprinted the article that Carl wrote in the first issue of the Planetary Report about why we're forming the Planetary Society. And it hits right on this point that you're discussing, which is missions are not happening. All of the negative decisions about the science budget, the decision was made by the incoming administration in 1980 that they were going to cancel planetary exploration. There would be no more planetary missions for a decade. And we're seeing that now. We're seeing the cutback that you referred to in the missions, the stopping of the Mars program, the stopping of the Outer Planets exploration program. It is a repeat of that same time. And I wish we did have Carl's voice, because that is exactly the whole raison d'etre of forming the Planetary Society is exactly being repeated today.
And of course, the Planetary Society is going to continue to advocate for funding for exoplanet research, for planetary science in general. It is one of our main initiatives. If Bill was here, he would be drilling it into this audience right now and talking about how important this is to us. And I'm very proud to say, Lou, that piece that that Carl wrote so many years ago has just been reposted as if it was a brand new blog entry from Carl Sagan on our website at planetary.org by my colleague Casey Dreyer, who was up here earlier this evening. So check it out. It's quite a wonderful essay. I am afraid that we need to move on so that we can get some of those young scientists up here. So we're going to have a little transition now, and we have something special to show you for that. But before we get into that, I want to give you a chance to thank along with me these four amazing individuals: Lou Friedman, Kip Thorne, Lynda Obst, and Chaz Beichman. Please join me in thanking them for being here. So, you've already heard another scientist mentioned a couple of times this evening, astrophysicist Neil deGrasse Tyson. He heads the Hayden Planetarium in New York. Neil also served as president of the Planetary Society. He remains on our board. In addition to all of his other efforts to share the wonder and power of science, Neil is now working with Ann Druyan, Seth MacFarlane, believe it or not, and many others to create a brand new cosmos for the 21st century. And it sounds like that was news to some of you, something to look forward to. They are in the thick of it right now. I happen to know someone who's here tonight, my old college friend, college radio friend, Sue Simone, has just been hired by Ann to be part of that organization. They have big plans. Watch for it. You'll be hearing much more about it next year. Neil regrets that he couldn't join us, but when I corresponded with him, he did ask me to show you this video clip from a public television conversation he had some time ago with host Ted Simons.
I know that Carl Sagan was an influence. Talk to us about that.
Yeah, he was, not that I was like drinking buddies with him, but we were sort of a generation separate, but I was applying to colleges in high school, and I already knew I wanted to study the universe at age 17 because I knew at age 9. So my applications were dripping with the universe. I was accepted at Cornell, and it's time to decide what school do you go to, and a set of other schools as well. The admissions office, unknown to me, sent my application to Carl Sagan. He was already famous. He was already on Johnny Carson, The Tonight Show, sent to get him to just comment on it. Carl Sagan then sent me a letter, hand-signed, saying, I understand you're considering Cornell. If you come by and visit, I'd be happy to show you the lab. And I said, is this Carl Sagan? Is this, I showed it to Mom, Dad, could this be? And it was. I wrote back and I said, yeah, we'll go up in 2 weekends. He met me on a Saturday morning in the snow, gave me a tour of his lab. I'm in his office, he reaches back, pulls out one of his books, signs it to me. The time for me to leave, he drives me to the bus station. It's snowing a little heavier. He writes his home phone on a sheet of paper, said, if the bus can't get through, call me, spend the night at our place. And I thought to myself, who am I? I'm just some high school kid. And to this day, I have this duty to respond to students who are inquiring about the universe as a career path, to respond to them in the way that Carl Sagan had responded to me.
Neil Tyson. So we've already talked about these young scientists, and some of them not even that young anymore, although all four up here very much in the young category. You could have gotten away with it, Emily. Who were inspired at one level or another by Dr. Carl Sagan. So we're going to talk a little bit in this very short segment as we near the end of our time here this evening. I'm going to start, though, I'm going to ask each of them, actually, we'll just go down the line, beginning with my colleague, Emily, and have them introduce yourselves. So, Emily, you go first.
Sure, I'm Emily Lakdawalla. I'm the senior editor and blogger for the Planetary Society. I've also recently updated my title to Planetary Evangelist. I consider it my job to tell people how cool the solar system is, with the cool things we're learning and the great questions that we don't know the answers to yet. And while I do that, I like to show people the amazing photos that all of the spacecraft across the solar system are returning to us right now. It's a pretty fun job, and I'm very happy to have it.
Take a look at the blog. You'll be amazed. You will also be joining I think most of the planetary scientists at work today who love to look at the blog and then bring up these images that Emily and her other amateur colleagues have put together and see, oh my God, look what they did with our data. So it's really pretty amazing stuff. Sarah.
Okay, I'm Sarah Milkovich. I am a planetary geologist and a systems engineer at Jet Propulsion Laboratory. I work at the intersection of engineering and science to do science operations on Mars Reconnaissance Orbiter, which is an orbit around Mars. I'm the investigation scientist or the representative at JPL for the HiRISE camera, and I'm also the science operations systems engineer for MSL, the Curiosity rover, where I basically do a lot of running around behind the scenes to make sure that the processes and all the tools are working for the scientists.
And please. So you guys know the HiRISE camera, most powerful camera ever.
The awesomest camera in the entire solar system.
You know what? They won't say this, of course, publicly, but it's looking for Martians so that Curiosity can go over and zap them with ChemCam. That's why we sent a ray gun to Mars, really.
Actually, one of the most awesome things about HiRISE is that you can go to the HiRISE website, click on the button that says HiWish, and you can ask HiRISE to take a picture of a spot that you pick out. So y'all really ought to do that.
Which you've done, right?
Which I'd done, and I got one of my HiWishes back this week, and it's the most beautiful butterfly crater I've ever seen because I picked it, so it's pretty cool.
Too bad it already had a name. Melissa.
I'm Melissa Rice, and I'm one of the scientists working on the Curiosity mission, benefiting from the hard work behind the scenes that Sarah is doing for us. I just finished my PhD at Cornell University last year and moved out to Pasadena shortly before the landing of Curiosity to start a postdoc at Caltech working with John Grotzinger, who's the project scientist on Curiosity.
And John will be one of our guests on December 15th. Please. And Vlad, finally you, and you're going to take us much farther out into the universe.
Oh, okay. Yeah. I'm Vlad. I'm from Rio, from Brazil, hence the accent. Let's see. Yeah, I did my undergrad there in Rio, and then moved to Chile for 1 year on a work that also took me to Europe, to Germany and Lisbon. And then for my doctorate, I went to Scandinavia. So moving from endless summer to endless winter there. And then for the postdoc, after my doctorate, I moved to New York, working at the Natural History Museum there, actually where Neil works too. Neil is quite fun, actually. He likes wine and cheese. Like we had many nice nights there. And then after that, I came here working at JPL, where I am one of the Sagan fellows that Chaz mentioned. And I work on the field of exoplanets. We have found more than 2,000 of those. My work is to try to understand how they formed. So what I do is that I run models of disks where those planets form, and then running these models with the most modern computational power that we can have. So the major computer that I use is one big cluster of not only one, right, but it's a big cluster of 100,000 computers that communicate with each other. Recently, I ran one model of one of those disks that ran in 18,000 cores at this same time. So
18,000 cores are individual little processors, all working on this model.
Yes.
Well, let's get to the heart of this. Thank you. If you want to hear a little bit more about Vlad, check out my blog entry at planetary.org that I posted yesterday, because Vlad actually submitted a little essay about his work and what Carl Sagan meant in him choosing this career. It's up at planetary.org, and it was posted last night. It's really quite good. What did Carl Sagan mean to the rest of you, to all of you? how much of a role did he and his work play in getting you to where you are? And who would like to jump in? Sarah, you're looking at me intently.
I'm actually looking at Emily to see if she was going to talk first. But, okay, well, I think my story is going to be a little different from the other people up here. I grew up in Ithaca, New York, where Cornell is. And when I was roughly 8, I was with my mother in the Ithaca airport, which is a tiny, tiny airport, 2 gates, one for arrivals and one for departures. And we were waiting for my dad, and I'm wearing a Halley's Comet t-shirt, because that was the year that Halley's Comet had come through, and I, being a huge space fan, we had gone and seen it. And my mom suddenly grabs me and runs over to this complete stranger and gets him to sign my shirt. And afterwards, I was like, what was that? And it was Carl Sagan. And I didn't really know who he was at the time, but then later on, we're driving down the road that I lived on, and we're about to go across a bridge, and my mom turns and points, and she says, that's Carl Sagan's house. And so it's a too far away for trick-or-treating distance, but it was still actually on my street. And so his house was sort of on the side of a cliff. There's a lot of gorges and rivers and waterfalls in Ithaca, and so you go along and you cross this bridge, and then you turn again, and if you turn your head and crane and look back, you could see the back of his house. And the front was looked kind of like a bunker, but the back, you could see his back wall, and he had this giant Pegasus on the back of his wall. It was this the old mobile Pegasus, the red Pegasus. And I just remember being fascinated by who was this person who was such a famous scientist and yet had this house on a cliff face with this Pegasus on the wall. And I think, what Carl Sagan was to me was a reminder. I watched Nova obsessively, I watched The Day the Universe Changed, I watched all these science shows, and it was a reminder that all of the scientists that I saw on the television, they were real people, and they had eccentricities, and they had, just goofy people in their hometowns would tell goofy stories about them and that kind of thing. And so that's what really resonated with me growing up, was that, these are real people and I could do that too. So that's my story.
Melissa, do you have a story to tell?
Yeah, I do. So a lot of the scientists that I work with knew from the moment they were born that they were going to be scientists. But my revelation came later in life. My first career was as a ballet dancer. That's what I wanted to be and was training very hard to be through most of high school. But I really can trace back my conversion to the life path that I've been on to an inspiration from Carl. So a lot of scientists always knew they wanted to be scientists, grew up reading sci-fi, had a chemistry set and a telescope, but I wasn't really that kid. I had more of an aha moment, a revelation, when I was taking this astronomy elective in high school, just kind of on a whim. And I had always liked science and math, but it definitely wasn't where I envisioned my career going. But we had just had a lecture that day on the future of the sun, and that the sun was going to die someday. And when the sun died, it would engulf the Earth and all the planets and everything we knew about it. And I remember I was brushing my teeth in the bathroom mirror thinking about this, and it hit me that, whoa, everything I know, everything I'm studying, history, art, philosophy, everything was going to be gone someday. And what was going to remain? Science. And I had this revelation that the only thing greater than myself is science, and that's what I have to study. So I had this very, it was an intellectual revelation, but it was also an emotional, and I'd call it a spiritual revelation too. And when you're a teenager, you have lots of very strong emotions, and that one might have just been another little blip on my emotional chart at age 16. But I went to the library later, and I was looking for books on astronomy because I had this hunger to learn about it. And I was fortunate enough to pick up Carl's books. And reading Carl's books spoke exactly to what I was feeling. And it might have been a different story if I had picked up a book that was more of an academic astronomy book, because it wasn't facts I was after. It was this sense of something larger than myself, this sense that understanding science can make the experience of being alive better. And so I was fortunate to find Carl's books and to read Broca's Brain and Contact and have a role model of Ellie Arroway as a female scientist who was studying astronomy and dating Matthew McConaughey. And so I think that really set me on the path that this is what I want to do. This is something worthy of devoting my life to studying. And so where my career led me from there happened maybe consciously, maybe subconsciously, coincidentally to coincide with a lot of Carl Sagan. So I went to Wellesley College to study astronomy, and my undergraduate advisor was a former student of Carl's. So I was Carl's academic granddaughter, you could say. And then I did a summer internship at the Arecibo Observatory, where Ellie Arroway starts out in Contact. And then I did my graduate work at Cornell, where Carl had been and where his picture was on the wall, and there's a great legacy there. And I worked on the Mars Exploration Rover program, and that brought me here to work on Mars, the Curiosity mission, the next step in our exploration. And now I get to be very actively involved in the Planetary Society, which is Carl's great legacy. So I feel very, very touched and moved by Carl, even though I never had the pleasure of meeting him.
And you know, you're still in dance. It's just the cosmic dance now.
That's true. I love it.
Vlad, you've got, as I said, your story on our website, but very briefly, as we get short of time here, talk about some of the things that you wrote to me about.
Yes, sure. I can trace to my interest in astronomy back to Carl. Okay, when I was a kid, like 5, 6, I already liked it very much by seeing the images from Voyager, from Jupiter, from Saturn. But then during teenage, I got other interests too. But then one day I saw this book here in the bookstore. Yeah, Carl Sagan's Pale Blue Dot. And yeah, I recalled seeing it and then biting my lips in anticipation to read it. And it was just, wow, magical. It was a book that captivates you not only by what he says, but also how he says it, right? The prose sometimes reads like poetry. The end of chapter 1, right, that became known as the reflections on a mote of dust when he shows the image of the pale blue dot, which was taken by Voyager 1. That's something that I read when I was 15, and I could feel tears, falling, and it was magical, really. And then I went on to the grad school, learned my physics, did my research. Actually, I have here my thesis, and I would like to show it, like not to promote
copies
it,
on sale in the lobby.
Yeah, not to promote it actually, but just to show that in the quote, I have here the pale blue dot image and that text. So Carl Sagan was a major inspiration. So to be one of the Sagan Fellows working at the JPL is an honor that I could never have dreamed of when I was 15 reading that book, that 15 years later I would be here to tell this to you guys.
Thank you, Vlad. Emily, as much as listening to their stories, I've enjoyed looking at how excited you are listening to their stories. You get the last word.
All right. Well, I guess, Carl, I was raised, I often say, by public television, by PBS. It was always on in the evenings in our house. So it wasn't just Carl Sagan, it was also David Attenborough and Philip Morrison and Jacques Cousteau, who were in my living room all the time telling me the messages that they had about the natural world around us. And later on, when we got cable, also Don Herbert, I think, is one of my huge influences. Mr. Wizard. And so the thing that unites all of these science communicators is the fact that they held this world in such reverence. They wanted to tell you about it because they loved it. They wanted you to understand it and feel the same sense of wonder that they did when they beheld it, because once you knew it, you would feel that sense of wonder at the same time. And that's certainly been a huge influence on me. I've always loved science. I thought I was going to be a paleontologist for a long time, and then I wandered into geology in college because it was the only science that I hadn't taken in high school. And then after I taught some middle school science for a bit, I thought, gosh, I wonder if I can do geology on other planets. And it turns out you can. It's really fun. And so, but as much fun as it is to learn about these things, it's much more fun to help other people understand them. And I think that's the inspiration that I got from Carl Sagan and all of these other people who came into my living room and told me about what was going on in the universe.
Thank you. Really, thanks to all of you for sharing these stories and for following these dreams, which are very much in the footsteps of Carl Sagan, Kip Thorne, and all of the other terrific scientists who are opening up vistas of the universe for all of us. We are just about out of time. In fact, we're going to be running over a little bit, so I hope that's okay with our hosts here at SCPR, because we have a couple more things to show you. I did promise you that we would show you a bit more of Cosmos, that personal voyage that Carl Sagan took in 1980. So we have that, and then one more very special item to share with you. But Jenny, let's go ahead and take a look at those few moments from the end of Cosmos, episode 13. You can stay.
These are some of the things that hydrogen atoms do, given 15 billion years of cosmic evolution. It has the sound of epic myth, but it's simply a description of the evolution of the cosmos as revealed by science in our time. And we who embody the local eyes and ears and thoughts and feelings of the cosmos, we've begun at last to wonder about our origins, star stuff, contemplating the stars, organized collections of 10 billion atoms, contemplating the evolution of matter, tracing that long path by which it arrived at consciousness here on the planet Earth and perhaps throughout the cosmos. Our loyalties are to the species and the planet. We speak for Earth. Our obligation to survive and flourish is owed not just to ourselves, but also to that cosmos, ancient and vast, from which we spring.
So not the end, just another beginning, and not the end of our evening, because I do have one more video for you, but I also want to renew that invitation for all of you to join us at MRO HiRISE. We have a flyer outside that Casey put together, which has the address and even a map. If you can join us out there, we've reserved the patio. They will be serving Cosmos, and you can join in the Sagan Slam. We'll hand you a microphone. So let's leave with this. It's a video that was created by John D. Boswell. He's otherwise known as Melody Sheep online. A Glorious Dawn has been viewed on YouTube 8 million times. Now, you might think that Carl Sagan's life partner, she who was most concerned with preserving and expanding his legacy, would not take kindly to an auto-tuned, copyright-violating mashup. On the contrary, here is what Ann Druyan told me on Planetary Radio not long after A Glorious Dawn premiered on YouTube. We'll follow it with the video.
I was completely uplifted. It was so wonderful to see Carl in the episode in Cosmos where he tried to do his impression of the humpback whale song. And to see him auto-tune to become the actual singer that he was in real life. He really did do a lot of singing. He was a complete music lover. Huh. He would have loved this, and I'm very glad that I didn't write one of those grumpy letters of copyright infringement to John Boswell, the extremely gifted mind and composer who created this. But instead, I spontaneously wrote him an email saying, Carl would have loved this. This is magnificent. You know, I've always said that science is a vision of nature and existence that is every bit as spiritual as any other devised by human beings. The only problem is we didn't have any good music. And when I first heard this, I thought to myself, John Boswell has actually given us a kind of hymn to reality. And the fact that it is hip-hop style featuring Stephen Hawking makes it just that much more astonishing.
I'm not very good at singing songs, but here's a try.
If you wish to make an apple pie from scratch, you must first invent the universe. Space is filled with a network of wormholes. You might emerge somewhere else in space, somewhere else in time. The sky calls to us. If we do not destroy ourselves, we will one day venture to the stars. A still more glorious dawn awaits, not a sunrise, but a galaxy rise. A morning filled with 400 billion suns. The rising of the Milky Way. Cosmos is full beyond measure. Elegant truths of exquisite interrelationships of the awesome machinery of nature. I believe our future depends powerfully on how well we understand this cosmos, in which we float like a mote of dust in the morning sky. The brain does much more than just recollect. It intercompares, it synthesizes, it analyzes, it generates abstractions. The simplest thought, like the concept of the number one, has an elaborate logical underpinning. The brain has its own language for testing the structure and consistency of the world. A still more glorious dawn awaits, not a sunrise, but a galaxy rise. A morning filled with 400 billion suns. The rising of the Milky Way. The sky calls to us. If we do not destroy ourselves, we will one day venture to the stars. For thousands of years, people have wondered about the universe. Did it stretch out forever, or was there a limit? From the Big Bang to black holes, from dark matter to a possible Big Crunch, our image of the universe today is full of strange sounding ideas. How lucky we are to live in this time, the first moment in human history when we are, in fact, visiting other worlds. A still more glorious dawn awaits, not a sunrise, but a galaxy rise. A morning filled with 400 billion suns. The rising of the Milky Way. A still more glorious dawn awaits, not a sunrise, but a galaxy rise. A morning filled with 400 billion suns. The rising of the Milky Way.
Ocean. Recently, we've waded a little way up, and the water seems inviting.
Thank you to Southern California Public Radio for hosting the Planetary Society once again in this wonderful facility and providing all of the support that you have seen this evening. As you leave, grab one of those flyers for MRO, our after party, and you might want to learn a little bit more about this organization that Carl Sagan and Lou Friedman and Bruce Murray founded years ago called the Planetary Society. We have volunteers outside there who are happy to tell you more. And lastly, thank you to those of you who've been watching us remotely, virtually, hopefully all over this pale blue dot via the live webcast, which will be made available. It'll be archived both by SCPR and by us at planetary.org. Thank you to all of you for coming out here on this cold Pasadena night and joining in this tribute to Carl Sagan and much, much more. Thank you so much, and good night.